this course. So now we will discuss on recursion. Recursion means when the function calls itself repeatedly. So let's have an example. Suppose your main function contains the statement print 5. There is a function print and you are passing the value 5 to this print function, and the print function uh, suppose contains the statement if a less than 1, then return, else print a minus 1. Then you are printing the value of this a. So in this case, what this will print? So from the main function, you are first passing the value of 5 to this print function. Then there is a condition if a less than 1. If this condition becomes true, then return statement gets executed. So first thing you need to keep in mind that every recursive function must have a base condition. It is called here the base condition. Based on this condition, the function stops executing. That means when this condition becomes true, the function will be terminated. So then this else part, then this print a minus 1, this function again called. So here the value of a is 5 for the first function call from the main. Then this condition here becomes false, so then it will come to the else part, then print a minus 1. That means here print 4. Then the program control will come to this point again. Then the value of a will be 4. Then this condition becomes false again. Then it comes to the else part. Then print a minus 1. This will be now print 3. So like this, this print function is called repeatedly. So what this will print now? So the first point is stack memory is used for recursive function calls. The data of the program are stored into the stack. So data means the values that you are using in your program. So here first function call is print 5. So the value of a is 5. So 5 is entered first into the stack. Then this print 4. The value of a becomes 4 here. So the value 4 will be stored into the stack. So stack is basically a last in first out list. That means the last element that has been entered into the stack will be deleted first. So then print 3 will be called. So the value of a becomes 3, that will be stored into the stack. Then 2, then 1. Then when the value of a becomes 0, then this condition becomes true. Then this return statement gets executed. So after returning from the function call, this printf gets executed. So then this 1 is printed and it is removed from the stack. Then 2 is printed and it is removed from the stack, like this. next 3, then 4, then 5 is printed and it is removed from the stack like this. So here the values are printed during the return from the function calls. So at first it may seem that it will print the values from 5 to 1, 5 4 3 to 1, but it will actually print the values from 1 to 5, because this printf statement gets executed after the return from the function call. So if you run this code, you need to first go to that particular folder. So then you have to first compile this code first, so gcc or cc, then the program file name recursion .c. Then to run this code you need to use this command ./a.out. You can see here now a.out has been created after successful compilation. So now you can run this. So look, it is printing 1 2 3 4 5. So this is the case for recursion. Now if I want to print the values from 5 to 1, then here it is printing the value from 1 to 5. Now if I want to print the value in the reverse order, that is from 5 to 1, then what we need to do? So here for this case this printf statement gets executed after the return from the function calls, right? So that's why it is printing from 1 to 5. So if you place this printf before this function call, then this will print the values in the reverse order, that means from 5 to 1. First print 5, 5 is passed, then the value of a is 5 here, this condition becomes false, then else part, then printf a, that means 5 is printed now. Then this print a minus 1, this print 4 is called, then the value of a becomes here 4, this condition becomes false again, then this else part, so printf statement gets executed, so it will print the value 4 like this. So you can check. So see, it is printing from 5 to 1. Just one change, you need to place the printf statement before this function call, recursive function call. Okay, so now if I write this statement, then a minus minus, suppose I change this statement to this print a minus minus, then what this will print? Then what this will print? You are passing 5, then 5 will be printed, then this function call print a minus minus, that means 5 minus minus. So let's see what this will print. Compile and run. Look, it is repeatedly printing 5. It is repeatedly printing 5, then there is segmentation fault, 1 error. So what is happening here? Here for this function call print a minus minus post decrement, So first the value of a is 5, right? So it is printing the value 5. Then you are calling this function again. So a minus minus, that means 5 minus minus. So when the program control comes to this point, so it is actually the value 5. So the same value is passed to this function because of post decrement. So this is same as print 5. So for the next function call, this the value of a is here still 5. So it is again printing the value of 5 like this. Then I have said that stack memory is used for recursive calls. So repeatedly you are pushing the value of 5 into the stack. So after some point of time the stack becomes full, so stack overflow occurs. Then this segmentation fault comes. So such kind of fault, such kind of error comes when the stack becomes full. So it is basically you can say an infinite loop. But if you write this statement minus minus a pre-decrement, then what this will print? For pre-decrement you are first passing the value 5, right? So this will print 5. Then here minus minus 5, it will be 4 for pre-decrement. So here for the next function call it will be 4 here. So for pre-decrement there will be no problem like this. So you can check, compile and then run. So it is printing the values from 5 to 1. Okay. Okay, so now we will have one program that we will write using recursion. So suppose we have to print the summation of the natural numbers, suppose 1 to 5 or 1 to 10 or 1 to 100. Then how we can write the program using recursion? So you need to go like this. First the number, that means up to which number you want to get the summation, int a. Then suppose s will hold the summation 0. You just keep in mind that whatever programs that can be solved using loops, those programs can also be written or solved through recursion. So now you can write this statement that enter the last number up to which you want to have the summation. So then scanf %d, then ampersand a. Then you are passing this to that print function a and s, right? Then it will be int a, then int s. If a less than 1, that is the base condition or terminating condition. So when this condition becomes true, you need to print the sum %d, then s. S will hold the summation. Then else you don't need to write this statement. So it will be s equals to, just like the previous program that we have already solved using loops, s equals to s plus a. Now you need to call this as uh, a minus 1 comma s. That's it. So this will print the summation of the natural numbers up to the value of a. So it is s, right? Okay. Now if you compile this, compile and then run, enter the last number, that means up to which number you want to get the summation. Suppose 10, sum equals to 55. So that means 1 plus 2 plus 3 plus up to 10, the sum of the natural numbers up to 10, that means n into n plus 1 by 2, right? So it will be 55. Okay, so the program is giving proper output. Like this, you need to practice some programs using recursion. So next we can do summation of the digits in a number, that we have already solved using loops. I have said that whatever programs that can be solved using loops, those programs can also be written using recursion. It is similar to the looping, because the statements are executed repeatedly for this case also. So here it will be enter the number, then scanf, then print s, then if a less than 1, it can be if a equal to 0, then printf sum, that will remain same, then else, then here you need to change, it will be s equals to s plus a modulo 10, because you have to get the individual digits from that number, right? So then it will be print it, here you need to change, it will be a by 10, then s. That's it. So this will give the summation of the digits in a particular number. So you can check it, compile and then you can run, enter the number, suppose 379, sum is 19, 3 plus 7 plus 9, 19. Okay, so it is working properly. Like this you have to practice some programs. Next we can do one more program to reverse a number. So let's do it. There will not be many changes, so it will be same, enter the number, then this a, then you need to pass this now as, then if a equal to 0, then printf, it will be reverse, right? It will be reverse, then return, then else, then s equals to, here you need to change, it will be s multiplied by 10 plus a modulo 10, then print a by 10 comma s, it will be same. So just one or two changes you have to make here. So if you compile this, then you can run this, enter the number. So suppose 379, so it is coming as 973 reverse. So it is working properly, right? So like these programs, you need to practice using recursion. Okay, so next we will see one more program like that we have solved previously using loops, that to check a number palindrome or not. Using the same code, you can check that a particular number is palindrome or not. So next we will do to get the factorial of a number, right? So it is let's do it. It will be, you don't need this, right? So suppose it will be fact int a, then factorial, then enter the number. That means of which number you want to get the factorial. Then you are printing the value, printf %d, then suppose the factorial equals to %d, then print, then you are passing the value, that is a, right? So here you also don't need this. Let's see. So here it will be if a equal to 0, then it will return, you don't need this, return 1, else return a multiplied by print, you can change this name, fact of a minus 1, right? You don't need this. That's it, you don't need this for calculating factorial, right? Then you can put this here. So it is returning one integer, right? So you need to change this to int. So I think it is done. The factorial, then this fact of a, you are passing the value to this fact function. Then if a equal to 0, or you can put it as 1 also, because factorial 1 also gives you 1. So return 1, or else return a multiplied by fact of a minus 1, like this. So if you look at the background, then what it will be? Suppose you have passed the value 5. So here the value of a is suppose 5. So it will comes to this part, return a multiplied by fact of a minus 1. So for the first case it will be 5, then multiplied by fact of 4, right? Then you are calling this fact 4, so it will comes to this point, the value of a becomes 4. Then this condition becomes false, then comes to the else part, then it will be this fact 4, it will be now a multiplied by fact of a minus 1. Now the value of a becomes 4, so it will be 4 multiplied by fact of 3, like this. Then this fact 3, you are calling this fact 3, then this fact 3, now the value of a becomes 3 here, so it will be next, for the next function call, it will be 3 multiplied by fact of 2. Then for this fact 2 function call, it will be 2 multiplied by fact of 1, fact of 1. So now a becomes 1, so it will return 1, so it will be 1. So this function will return this product like this. So you can check, if you compile this, then you can run, enter the number, then suppose 5. So the factorial is 120, you can see here 120. So like this recursion works.